Fantastic. First of all, thanks so much, Daniel, for inviting me again. A couple of words about myself. My name is Alex Coqueiro, and I'm responsible for the solutions architecture team in Amazon Web Services, more specifically working with public sector customers, which is basically government, education, non-profit organization, and healthcare in Latin America, Canada, and Caribbean. And I'm here today to talk about graph databases, which is an area that has been growing a lot, especially the last 2 years, because graph technology is very handy to present data, especially when connections matter. And if connections is not something clear for you at this moment, don't worry because we'll talk a lot about it, a lot about relationship and data links. And I'm pretty sure that by the end of the presentation, those concepts will be far more clear. The way that I plan myself today is covering three major areas. First is use case, because I'm not assuming that you have a previous experience with graph database, and I want to be sure that you have a couple of examples that helps you to understand when you should use graph database or not. The second one is about technology. And yes, I'm working in AWS, but I want to be more agnostic as possible because, pretty sure that maybe we use your use case combining the building blocks that I'm present today, maybe not. So my intention here is provide you the best that I can to give you the foundation to use the technology very, very well. And the last is the demo. I truly believe that when you see things running, it's much more easier for you to understand. And the reason that I have a use case that helps you to understand or see things with your eyes about how things work. By the end of the presentation, I will share some links with has the demo. Like if you want to install the demo by yourself, you are more than welcome to do so, as well as some documentations and two books. Those two books are free, but are just an excellent source of information to dive deep in areas that I will speak today. So that's our plan for the next 50 minutes. So I think it's like any kind of start. I think the first point is what is this all about? What graph technology is all about? And basically, I just like to go back for 1736. Yes, many, many years ago. The mathematician Leonard Euler, he was living in Prussia, now is a Russia, in a city which calls a Königsberg. So in that place, there's some small islands which is linked by bridges. And what he Leonard tried to convey was a mathematical formulation that helps people to cross the bridge, going to all the places, but not cross the bridge more than once. So the idea is how to provide the best optimized model to cross all the streets, to cross all the bridges without cross twice. Uh, in the end, was a very interesting because he proved that this problem has no solution. Actually, he wrote a paper, but despite the fact that he didn't find a solution to cross the seven bridges of Cronenberg, his concept or his knowledge was the foundation for graph. Because for graph, different than traditional database or traditional information, is not the data only that matters, but also how the data are related each other. Remember in the beginning of the presentation when I mentioned about connections, that the connection I'm talking about. Bridges are really easy way to understand those connections because you link those islands is exactly what the Cronenberg or Leonard did. In terms of concepts, there are two major concepts about bridges or actually graphs. The first concept is a vertices or nodes. You can use those words interchangeable. Vertex is about the domain or the data domain that you want to store your information. Customer, people, store, any kind of domain that you want to store, you can store in a vertices or nodes. If you have a database experience, you can think about vertices as a tables. And the second one is a edge. So edges, like these red lines that you can see in this graph, is the link between the vertices. Is the edge that you can store the information that will be the foundation to understand how things are related each other. With those two concepts, now we can go to our days. So different than 1736 with Leonard, now the world is far more connected. And what you can see is the use case for graphs everywhere. And probably not the first use case, but one of the most famous use cases are about social networking. So the foundation of the big social networking, like Facebook, Twitter, Instagram, among others, is the fact that many times you don't want to talk with your friend. Sometimes when you publish a picture or a post, you want to show or share with it with the friend of your friends, or how the friend of your friends know who you are, how connected you all are in terms of making sure that the timeline that you have in your social networking will provide only relevant information for you. It's a classic solution for a classic problem for graph databases. If you work more in an enterprise environment, a great user case is a customer 360. So when you see customers today, many times those customers have been touched for several channels like mobile, call center, or even when customer complain about it. And all the systems are not necessarily integrated. So the customer 360 as a solution try to have a single view of the customer. Doesn't matter where the information comes from. Another great example about graph database, because you can ask questions to your model and your model will be able to navigate and find information about specific customer behavior. Or if you go to knowledge graphs, and let's take one example from healthcare. Today we have a lot of information about drugs, information about medical procedures, and when you integrate graph with other technologies like machine learning, especially natural language processing, you are able to get the text, extract the information that you need, and then you can link this information using different correlations, especially to find what you need in terms of connections. In science, things like protein research, and actually there's a lot of examples in the biology area. Actually, chemistry was one of the first areas that leveraged graph concepts because it's all about DNA and how DNA has influence with other aspects of DNA. Again, relation between different cells. Recommendations, think about Netflix. And Netflix actually is a big user of graph databases. And when you think about recommendations, it's all about how to correlate what you like with other people that might be connected with you. And obviously, when connected, we assume that these people they have similar areas in common in comparison to you. Or fraud, like when you think about fraud, there's a million ways to make fraud and people are getting more and more creative about those techniques. Another area that you can use a graph to understand how those different techniques are related to each other. And you go to IT in general, like if you want to analyze data to identify some security breach, yeah, graph can help a lot on it. Or robots in an area that I work in Amazon as well. If you want to provide automation to your robots fleet and create optimization, you are more than welcome to use graph database. Or if you work in a supply chain and you want to create some optimized models to deliver products, again, graph can provide such a great area for you to explore those different use cases. So as you can see now, there's a lot of use cases that you can use graphs that provide you what you need. So let's dive deep one step further to see with our eyes what happened behind the scenes about graph database. So I'd like to give you some seconds for each one of you to see this graph. Like let's say that you have a representation of people in the database. You can see people like Alice, Bill, and Bob. You can also see places like Paris. You can also can see the museum, the Louvre, or places like the Eiffel Tower. So all those things are related to each other in our model. So it's very handy when you think about questions that you'd like to ask to that model. Let's see some examples of questions. The first one, and I'd like your help to answer this question, is who painted the Mona Lisa? And I know that most of you know on top of her head. Don't worry. I prefer that you go to the model and try to identify how can I find this information. So first, that the graph database go do the behind the scenes is identify the vertices or the node. As you can see in the middle of the screen, you have Mona Lisa. And then you have the edges, which link the information between different groups. And you can see Leonardo da Vinci. And you can see a relation or an edge which link both, saying, hey, Mona Lisa was created by Leonardo da Vinci. So for the question, who painted Mona Lisa, the method behind the graph database is exactly what I described to you. Identify the node, identify the relationship, and then provide the answer that you want. In that case, Leonardo da Vinci. Let's take one second example, but second example is a little bit more complex about graph database. The question is, what museums should Alice visit in Paris? Let me link my pen here. Here we are. That's Alice. And you see there's a different ways that you can get this information. First, Alice is in Paris and she visits Eiffel Tower. And Eiffel Tower is located in Paris. So you can see that Louvre is located in Paris as well. So it could be a good relationship or a good suggestion to Alice, hey, consider that you are in Paris, go and see the Louvre. But in a graph database, you are able to have different connections which goes to the same information. Let's explore a second path. Let me just change here my pen, the color of my pen, blue. And Alice is a friend of Bob. But Bob is interested in Mona Lisa. And Mona Lisa is in Louvre. Assuming that Bob and Alice talk all the time, there's a good chance of someday Bob just say, hey, Alice, Mona Lisa is just amazing. You should go there. And it's a kind of recommendation that the system could go to you, like based on the fact that you know both know Bob and Bob like Mona Lisa. You can see like, hey, it's just a good suggestion. Not that different than in real life. The third example, what artists have painting the Louvre? And again, let's go back to our model. Louvre is there. At this moment, I have just one relation, which is Mona Lisa. But the beauty of graph models is the fact that you can start expanding and adding more and more information in your tree. So in that case, imagine that I have all the paintings in that database, in that model. Would be super easy to go there and identify. Not only we have Leonardo da Vinci there, but you have many others as part of your model. So the way that we just describe each one of these vertices and the relation with the edges is how the graph database works behind the scenes. Let's see now an example in a real life. And I really like this example because a good combination between graph and AI and ML. So Babylon is a health tech company based in UK, and Dr. Ali Parsa is a person who developed a very interesting solution that provides a different customer experience for the patients. So what the Babylon solution does is providing the communication between the patient and all the database that Babylon has behind the scenes and provide the best answer in order to support all this clinic advisory. In that case, before I start talking about this case, let's see how things work in real life. So I will show a video for you about the communication between the patient and the Alexa, and you see behind the scenes how the information just go and get navigation properly way. Let's do it.
Alexa, I want to talk to Babylon.
Hi there, I'm Babylon and I'm here to help. To start, tell me what symptom is bothering you the most.
Well, I've got quite a sore stomach.
Sorry to hear that. Let's figure out what's causing your pain and how to treat it. Chris, where exactly is the pain?
It's kind of on the top part of my stomach, sort of in the middle.
And how bad is the pain?
Oh, it's not too bad.
And does it come and go?
Yeah, it comes and goes, and it's worse after eating.
I see. How would you describe the pain?
Sort of feels like a burning pain.
Okay. And are you feeling sick?
Yeah, a little bit.
Have you vomited at all?
No?
Have you noticed you're feeling fuller sooner than usual?
No.
How long have you had this pain?
A few months? 3 months, maybe?
Are you still a non-smoker?
Yes.
Okay, that's great. Have you been taking any of your ibuprofen tablets the last few days?
Yeah, I have.
Thanks, Chris. I know enough now to offer information on what may be causing your symptoms. It could be acid reflux or a peptic ulcer. I'd recommend speaking to a GP soon. They're likely to prescribe something called the proton pump inhibitor to control your stomach acid. I can then get this prescription to your home using your Amazon Prime.
Okay, thanks, Babylon.
My pleasure. Thanks for using Babylon with Alexa. Goodbye.
Yeah, that's it. I think this solution that you see today is not like a proof of concept or a demo. It's a real solution that's getting bigger and bigger in UK as well as Africa. It's the two areas that are expanding. But as you can imagine, especially in COVID times, it's really, it's probably the solution you expand for other regions super fast. You see, in terms of Alexa, is the integration in terms of communication, but all the intelligence about finding the best procedure or create the interaction, it's what's stored in a graph structure. It's a great example of how customers are leveraging graph technology for real solutions. And you can easily apply those concepts for different use cases. When you see social networks, for example, people are the center of your model. But if you go, for example, for a recommendation for restaurants, it's not only people, it's about the food, it's about the place, and how those things are related to each other. You see, visually, you can see some differences in terms of model in comparison to social networking versus recommendations. And if you go to retail fraud, again, new example, we combine a lot of information like IP address or the city or a country. You see, you're adding geographical location as part of your model. You see three examples, three different models, but provide the same user experience, which is a very easy way to navigate in terms of data. With all this foundation about the user case, let's go to the technical part and let's start talking about architecture. And obviously, there's several ways to develop the architecture for graph solutions. I just select here the three major building blocks, which are very common when you talk about this technology specifically, which is data store, the way that you store the information, the query, how you can find the information in your graph database, and visualization, how you can see the information to navigate through the structures. Let's start for data store first. And when you think about data, usually people think about relational database, which has been in the market for years and years and has been doing such a great job about storing data. The problem is when you think about highly connected data, there are some challenges about the model. Let's explore it. So here you can see the table employee, and you can also see a table skills. So here, if you want to create a relationship, or if you want to connect the data about employees and the skills, what do? Some modeling like many-to-many relationship. So we create this temporary table in the middle, employee skills, and start to have the cardinality or the integration between those two tables. This model is useful and you can apply for a lot of different cases. But when you think about highly connected data, this model brings you a lot of challenges. The first one is about data domain, because basically, as you are adding more and more models on top of your database, you start getting so challenged about how to model in this data. Imagine if you have 10 different domains and I need to create a many-to-many relationship for all those 10 domains. It's hard and usually creates a lot of maintenance and problems about how to keep the consistency of your database. The second problem is about flexibility, because when you think about highly connected data, you need to be able to model different relationship, and different relationship, they have different properties because they are very flexible in the way they communicate each other. And again, we don't. When you think about relational database, you are thinking on schema on write, which means that you need to define the model first before writing the application. That with highly connected data, that the data change all the time is not actually a good approach. And the third, and probably the most complex one, is about queries. Because when you have multiple tables with many-to-many relationship, if you want to cross information from different tables, you probably need to use joins, and sometimes those joins can be super complex. The solution for that is graph, because graph basically try to break your domain into small chunks. So it's not about the entire model by itself, but it's about each node or each vertices that you have. And for each one of those vertices, you have connections, or you have a way to identify the relationship. In that case, you have the employee, you have the skill, and you have this relationship with skills this employee has. It's much more natural for the questions perspective how the model store this information. Because in the end of the day, highly connected data or graph is all about relationships. It is what this model does so well. So base graph database is how to store and retrieve the information in a very efficient way using highly connected data. You have several approaches or several ways that you can do it. And one of the examples is leveraging the solutions or open source that are available in the market. The first example I like to use is using AWS Marketplace. Today we have more than 1,400 ISVs in Amazon publishing solutions, more than 1,400 products listed, and there are several of those products that are solutions that we can use for graph database. In that moment, let's start our demo session. And here I have the AWS console. My apologies if you have never seen the AWS console before, but explain AWS in 30 seconds. So basically, this screen is the catalog of several services that you have available in a cloud. And one of those is the marketplace, the one that I mentioned to you, which provides a catalog from different vendors. If you go to discover products, and you go there and say, hey, Amazon or marketplace, tell me which graph databases you have available that I can launch in my environment. One example is Neo4j. Neo4j is very popular graph database. Uh, they have several versions like Community Edition, Enterprise Edition. If you want to launch it, just click here, and then you'll be able to deploy your environment using this Neo4j graph database. I think one of the benefits of graph database, or sorry, Neo4j, is the fact that this solution was created from ground up to really be sure that to be able to leverage all the benefits of this technology. But Neo4j is not the only one, and you have other approaches. Let me go to the second screen. You see that several available in the market today, but I really like this one, Agents Graph. And I really like Agents Graph because basically Agents Graph leverage a relation database. Look how crazy things is. Like behind the scenes, Agents Graph are using Postgres, but Agents Graph provides you a layer that creates all the translation in terms of queries, leveraging all the benefits of Postgres, especially extensions in that platform. Another approach that you can use. When you go to the GitHub, there's many other solutions. And one that it's, I'd say, a kind of popular, it is one from GitHub. Let me just yeah, because I changing the mouse here. Now, yes. It's the GitHub. Let me click in here. And the Genus Graph is a different approach because it's an open source project. You can go there and install in your own environment and cloud on premises. And behind the scenes, Genus Graph will install all the interface with Graph using Amazon DynamoDB, which is the NoSQL database from Amazon. You see, interesting because in that case, agent solution use Postgres, or solution use DynamoDB can be used behind the scenes to store the structure that you can use. Two approaches. The benefit is you have full control about the environment. The problem is you need to take care of your structure. And probably, if you have been working with Amazon before, you are familiar with the managed service. There's several services today like RDS, Relation Database Service, that provide you all the automation to eliminate all the undifferentiated heavy lifting in your application. So instead of you managing the clusters, the high availability requirements, you can just delegate to your cloud provider, in that case, Amazon. Examples of things that you can use is like using the console easily, having features like a backup restore that you can leverage if you need to, especially think about high availability using techniques like multi-AZ or multiple availability zones in order to create scale to our environment. When you think about graph database, one critical aspect of the integration is read replicas, because there's a lot of queries to get the information that you need, and you can scale. And security. I work a lot with governments and healthcare, and security like job zero is absolute mandatory, and managed service provides these solutions for you. The name of the solution in Amazon for a graph database solution is Neptune. So I don't want to dive deep much in Neptune today, because I want to keep as agnostic as possible. Because today is all about give you the options, but in a very high level, the way that Neptune works is they have the core, the engine, which is represented here in these blue boxes, which provide asset consistent, strong consistent to our database, like relational database. They provide all the interface to integrate with external systems. Let's say that you have a data in your S3, which is our storage service, and you want to import this data, you can use Neptune to provide this integration. There is an interface that I will talk more about those interfaces very, very soon. Gremlin and Spark QL, you see examples about how using both, that has an interface between the engine and your application. And behind the scenes, you have a Neptune as using the cloud native storage service, which helps in terms of scalability. Let's go one step further. And probably if you go to the internet, you find a lot of articles which says, hey, graph database is cool, but not scale. Our graph database is a great start, but when things get more complex, this one gets ugly. And actually it's true. It's the main reason that we developed that solution, because you see a lot of value, but you need to have something that is really scalable. So the way that you did it is decoupling the transaction caching and the interface from the storage. So basically, when you store information, we just replicate this data 6 times across 3 availability zones, which is basically a combination of data centers which are located in different places. And 6, because if let's say that one of these availability zones or one of these facilities just stop working, like let's say that you have a connection issue, the data that you have will be there. And behind the scenes, Amazon will be able to redirect your primary compute engine to a different server, and then the information will be there. The information will be available in this share storage volume. That makes super easy to backup, makes super easy to scale. That's the reason that you are able to have 15 read replicas as part of solution without affecting the performance. Again, if you have experience in Amazon, you can think, hey, I think I've seen this structure before, especially for a relation database with Aurora. Is this the same technology behind? Yes, it is. So the idea is we leverage a lot of knowledge, a lot of experience for Aurora, for Postgres and MySQL, and we apply the same approach to Neptune in order to create this very scalable environment. Before going to the next slide, which is about the example, let me quick read the question here. We also have Neptune offered here AWS. Yes, we have several options, as you can see. It's all up to you which one makes more sense for your business. GraphDB better than NoSQLDB? I think it's a big depends. Because depends on what you want, depends on the performance that you have, depends on the model that you want. I think the question here is, you have 2 options. For GraphDB, you have a specialized engine to do endurance queries, which is in general faster than the pure NoSQL DB. Not because NoSQL DB is always slower than GraphDB, it's much more because the way that we store all those adds and nodes makes much more optimized when you have like an engine that is totally designed to address those kinds of use cases. But honestly, the best way that you can do is testing. And I think the beauty of using cloud providers, testing to see which one works best for use case. But in general, GraphDB performs better because it's more specialized. Used to solve totally different class of problems, yes. Yes, I talk more about different class of problems very soon actually in this session, because at this moment, I just show you the infrastructure behind the scenes, and I like to show how you can use it. Great. So now we understand what options you have, but remember what I told you in the beginning. I told you that I'd like not only show the concepts, but also how things work in terms of demo. And obviously for the demo perspective, I need to pick one, and I pick Neptune, just as a matter of specialized graph database for our demo to develop things from scratch. Now I'm going back to my console. And now when you go to AWS console, you have a session for database. And one of the database is here, Neptune, which is like the graph database which from Amazon. We click here and the graph database. And actually I have the two that I use today. But if you want to create one from scratch, the only thing that you need to do is create database. In create database, you define which version of Neptune would you like to use. I use the last version, the name of my cluster, cluster demo today. You have several templates, like would you like to deploy the solution in the production mode, or would you like to deploy it in a development testing? You see, you have several options that can help, that there are different requirements about high availability. You can also choose what kind of instance is has a better fit for our environment. Here is different. That's not like EC2, our virtual instance service that you go there and manage the server. Here, use it only as a background to understand the capacity that you like to deploy to your environment. T3 is a very cheap instance, but you have others like R5 and many other families that you can use. Let me see one here. Like you have families like R5, 12 large with 48 CPUs, 384 gig of RAM, and 7,000 megabits in terms of connection with BS. Again, the best one depends on the performance requirements that you have. I don't need this big solution for my demo specifically. I can use this one, it's small, because I don't have a lot of data. Then as soon as you pick your instance family, the next step is about multi-AZ or multiple environment that can create different availability zones, semi-availability zones, information about VPC. VPC is a virtual private cloud, which is all about networking information that you like to set in your environment. All this information here, the TCP IP port as well, that you can change as if you need. The last set of configurations is about profiles that you have access to a very low level fine-tuning. In terms of database, you can go and change those configurations. You can change how you'd like to connect in terms of user authentication. You can define your backup policy, and you can define your encryption. You see, most of these options are there are standards or a default parameters, or if you want to customize, you are free to do so. And here, create database is about creation. And then behind the scenes, Amazon will provide all the physical infrastructure as well as the software to provide all the requirements which was selected in a step before. Good. Now we are ready to go to the use case, because now we have the infrastructure. And what I'd like to do now is show you some examples about how you can use that infrastructure that you just created before. And if you think about the structure, we think about queries, are basically the way that I interact with my data. If I'm talking about relational database, it's easy, it's SQL. But if I'm talking about graph database, different conversation, because we have more than one model available. Let's dive deep on it. Let's see which options do we have. So about graph models, we have two big options. The first is a property graph, which is probably the most common and the most famous. And the second model is RDF, which is Research Description Framework, which is actually the oldest one. Actually, a lot of models were created using this kind of approach. Let's use both, because I know that, oh, sorry, there's some noise here. Now the police just gone, thank you. We have model, there's some developers or people who likes property more. There's people who like RDF more. What I can tell you is both approach, they address the same problem. Means that you are able to achieve similar results on the property or RDF. It's more about how do you like to use or how do you like to create your implementation. There's some difference in terms of approach, but like in a very simplistic way, both can do the same thing just in a different way. Let's start by property graph first, which is more aligned in terms of concepts. We have the concept of the vertices that I explained before. Sometimes you say vertices, sometimes you say nodes, depends on technology that we are using, which is basically the representation of the entities or domain. We have the edge. We spoke a lot about edge, which is the link between the vertices. And now a new concept that we call a label. Label is a way to identify your ads. In that case here, you have a user, Bill. You have another user, Sarah. And the label here is friend. What is the definition which represents the link between these two data. For each vertex or edge, we have a unique identifier. Think about your unique identifier as a primary key. It's exactly the same. You can navigate through the properties, or you can navigate through this unique identifier. And for vertices and edges, you have properties. And that point is different when you compare to relational database. Because when you have two tables, you created a table, an intermediary table, but the relationship don't have properties. Here we have. So as you can see, friend, they are friends since when? And have a data. In that case, I have just one data, one property to my edge. But as you can imagine, I can add as many properties as I want as part of my relationship. Another important thing, sometimes the same vertices, they have different edges. Like they are friends, but they also work together, or they are members of family. All that stuff, you are able to represent in your model. Technology, like now you understand the foundation of property graph, what technology you can use. And you have some very interesting open sources available in the market today. And one of the one that's getting more and more popular is Gremlin. Gremlin is what you call as a transversal language that allow you to navigate through all those nodes using the edges. Gremlin as a notation, they need some technology to implement the communication, and one of the most popular one is Apache Tinkerpop. Apache Tinkerpop is available in Neptune as well as other cloud providers, It's like this combination Gremlin and Tinkerpop is getting super popular. I will show you some examples soon. As I mentioned, I think the beauty of Tinkerpop is the fact that it's open source, meaning that if you want to create your own Tinkerpop server, you are more than welcome to do so. Obviously, if you create things by your own, you must be aware about scalability requirements, but you are free. It's all up to you what you want. And Gremlin is the transversal language that helps analyze the graphic. And as I said, Neptune implemented both. Here's an example. You have commands, and those commands can create vertices. These commands can create edges and connect all this data. Instead of going details about it, let's do something together. Because remember, I created database before. Now, when I use this database using Tinkerpop and Gremlin. Now I'm again changing to my console, and you need some interface to send the commands. You can send commands using your application. You can write a code using Java or Python or other languages that support to Tinkerpop, or in the case of Amazon, you can leverage the power of notebooks. And notebooks is very popular when you think about AI and machine learning, especially about Jupyter. And the way that we implement is putting this notebook as the front end to the database. If you want to create a new notebook, it's a very straightforward operation. Just go there, create a notebook, and you can say which cluster I'd like to create. In that case, cluster demo, the one that I created step before. I define the size of my notebook instance, security information, and that's it. Oops. Demo, my IAM, which is my security role. I want to create a new role. Yeah, but without the notebook name, that's impossible to do it. Toronto meetup. To define the name of my notebook instance. So again, sorry about this mistake. You define the cluster, the instance type, the instance name, your IAM, which is a security, and now you can go. Here we are. Now, what's happening behind the scenes is Amazon is leveraging another service, which is specialized in machine learning. We call the service as a SageMaker. I'm not talking much about machine learning today, but as you can see, those both things are integrated. I have one environment here, which I deployed before, using exact same steps that I showed you now in order to provide you the full experience. So I have here open notebook. And what you see is a very traditional screen from Jupyter. Probably if you have a data science experience before, you'll be very familiar with this interface. So basically, you have a folder here, a meetup, and I create a notebook or an interface to my graph database from scratch. When I create new, I have several options here, like using PySpark, Spark, R, Python, different pros like MXNet, TensorFlow in terms of machine learning. But today let's keep things simple. I use Python as my interface. So here I have a notebook on Python. What I need to do is just tell to my notebook that I'm using commands from the Tinkerpop, which is basically created the interface to my database. Have here our first command this night is value map. So let me explain everything that I did now. First, a magical word, Gremlin, because from now on, the notebook knows that everything that I'm typing after that, it's a Tinkerpop, or actually a Gremlin command. This one is like a select star from table. Like I want to list everything that I have in my table. I have here some data, but actually I don't want to use that data. I want to clean everything because I want to create things from scratch. How can I do it? G is the representation of my graph. V, my vertex or my vertices that I don't want to specify. I want to put some command that applies for everything, and drop. And drop is a command that you can use that delete all the information. Oops, no, it didn't work. Now working. Some type mistake. Here my database is empty. Like now I have nothing, I have no data, because again, I want to create things from scratch. And our first operation now, it's about collecting information from the regular citizens. Let's say that we are working some solution for contact tracing. Let me just go back to the screen because I think it'll be easier if I show you this image. So what I'm trying to do now is I want to create a solution that helps you to identify who are infected by COVID, as an example. I know that people are sick and tired of hearing about COVID, but actually graph database works so well when you think about graph information. But basically, what I'm doing first is start adding information. If you are living in Canada, I know that we have people from Canada and outside of Canada, but we are from Canada. The First Minister just announced last week an app that you can install in your cell phone that helps you to notify the government if you are sick. So let's say that you download this app and now this define, hey, I want to register myself. What happened behind the scenes is graph database. I add my data. And here I have the minimal command, G as a graph, add V or add vertex, that I'm adding one vertex in my graph, like one circle that you saw before, is a person, is a definition that I have. And this person has a property that in this case specifically, the property is a name. So the space is Daniel. I just put Daniel in to say thank him to make this presentation today possible. But let's say Daniel just download the app. Hey, I want to provide information to the government. And yes, I want to register myself. Behind the scenes, you have your information in your graph, like I insert, just what I did. So, but now we don't have Daniel only, because Daniel alone doesn't help much. We'd like to have more people, because more people just download that information. And now I'd like to add multiple data. So now what I mean, you see that the structure of the command is about the same. I'd like to add a new person. A new person, I'd like to define an ID, like a primary key. You see that before I didn't. I define like a standard key. Now I define the key that I want, a name, and the name is Alex. And a second person, the second person calls Sueli. Means at the end of the command, I have 3 people in my database. But now I think it's the beauty of graph database, because remember, I told that the graph is all about breaking domains into data. And then as part of data, I'd like to create something totally different, which is a place. And there's 2 places that I'm adding now. First, Sushi Place in Toronto, and Burger Delicious is 2 places that I have in the city. And now I'll add this information, and now I have 3 people and 2 places that I'm monitoring to see like cases of COVID. And now imagine that people are just in the street and things happening, and these 2 people, Alex and Sueli, they just went to some places. And your app, you record that information. So have Gremlin here. Let me just expand. The vertices. One is Alex. This person because this person was there in Sushi, Toronto. The person number 2 also went to Sushi, Toronto. Probably they went there together. The point is, in this relation, I just add one more property because I identified that moment that place was infected. Means that now the infect is not the only person, but the place by itself. That's the relationship that I was talking about. And actually, as soon as the number two, who is Sueli, went to Sushi Toronto, she also went to Burger Toronto or Burger Licious, name of second place. The place was not infected, but this person were there. Now I just add this information. Now I add all this relationship. Now I'd say that I have a full graph model. I know it's very, very simple, but I have a full model with vertices, with the edges and things connected. Now is the time for asking questions to the model. And you can ask very easy questions like, what the people that I have using my app? Like let's say that I want to list all the users. You see the structure the same, graph, vertices. Now I want to find not everything. I want to find people. In that case, I want to find the vertices, which has a label, which is person, and I want to list the name of these people. As you can imagine, we have three people, no surprises, Sueli, Alex, and Daniel. But the information doesn't help me much because now I know that Sueli is infected and I want to ask which places Sueli did it because I want to provide like a plan to try to close the place or create some special procedure to clean that place. How can I do it? Just a one single command. So in that case, Gremlin, graph, the vertices has, because I know a person and this person is Sueli, and where she was. Actually, my grammar, I just did a mess with my grammar now. But where Sueli, which place Sueli were, because I want to have a full analysis to identify the virus. And here, they provide the connection. So Sushi Place and Burger Delicious were the place that I asked to my model in order to get information that I need. So the simple model just follow the regular steps about everything that you need to consider in order to create your own model. You see that in no moments I create any kind of structure. Everything that create from scratch, but look like how easy or how natural I can write those queries in order to get this information. As I mentioned, there's a book that I will share in the end of this session that compare several SQL queries versus transversal queries, the one that I showed today, and see like sometimes you have like 20, 25, 30 lines of one SQL query with join, multiple joins, and you can translate all those queries to one single transversal language because it's more natural in terms of queries. Let's go back to the presentation. Now we just identify the place that Sueli was. And you see examples about Tinkerpop. So I went with much more details than the slide. But Grammarly and Tinkerpop is not the only technology that you have per property graph today. One popular approach is OpenCipher. Actually, OpenCipher is an open implementation from Cypher. Cypher is implementation for Neo4j. The idea is the same. The only difference is they have a different notation that helps you to navigate. But Grammarly and OpenCipher are two examples of technology that you have today that helps you in terms of navigation. I mentioned about the RDF. Let's go to RDF. The first thing about the RDF is RDF as a standard from W3C, different than Tinkerpop and Gremlin, Neo4j and OpenCipher. RDF has a standard that is approved today. And you can write your queries using Spark QL. And maybe you are wondering, hey, if you have a standard, why not using RDF specifically? I will show why. So, but to show why, let me explain to you first how the query works. For RDF is a very web oriented. As you can see one query by three different structures. One's a subject, was a predicate, and another is an object. So the way that they define this structure helps you to store each information. And then you can create a links, like I define my new subject here, and define that my predicate is a friend, and then I link things. As you can see at first, RGF are more verbose. It's as a fact. Sometimes people like, some doesn't. But for me, the biggest benefit of using RDF is the fact that there's a lot of data available in RDF format. So if you have this case, definitely using Spark QL will be a great solution for you. Let's go to the demo to show you a quick demo using Spark QL. You can use the same notebook that we're using now. I have one demo here that I did before. The magic word is, instead of Gremlin, we can use Spark QL, and then you have this structure, insert data. And say, hey, Alex, interesting, because when I run this command, here I just have a JSON structure. It's very similar to SQL. Yes, it's true, especially for insert and document. It's very similar to things that you do now, especially have experience in relational database. To search information, you can use select, very similar. In that case, I just list the information that I have in my database now. I think the tricky part here is the join, because as your model gets more and more complex, you see that for transversal queries with OpenCipher or Gremlin, you do things easier. In RDF, sometimes can be tricky the way that you structure information. But again, it's a kind of personal preference. If you're using Neptune or using Jupyter, you can pick one, or you can use both. Like, there's no restrictions about the way that you can store and get information. If you want a recommendation, hey, Alex, I don't know which one I should pick, which one should I start? Definitely, I would recommend using Gremlin and Tinkerpop, because it's very popular, it's open source, very easy to get started. Super. We saw Gremlin, we saw RDF. And the next question about visualization. Like, we saw tables here. Yeah, good, because you are able to identify information, but it's not much in terms of visual aspect, was not super beautiful. So how can I see the information in a more elegant, on a beautiful way? Let's go deep in terms of visualization. And actually, I select 3 today, but there's many. There's many options in the market today. If you have something that's different from the list that I showed today, feel free to use. This one is usually the one that I work more with my customer, or my customers ask me, and they decide to share with you. But by no means, the list is just the one that you have here. I would be surprised if you have something better than this list. And please, if you have one, please, more than happy to hear your opinion. But let's talk for the Tom Sawyer first. Tom Sawyer is a solution which is available in the marketplace. The company is Tom Sawyer, that provide a very nice user interface to do your queries. I install my environment. Let me just close those notebooks, otherwise I make confusion. And I have here my EC2 service, and I have several instances here, and I just install the Tom Sawyer as part of my marketplace. It's this service that I have here. I open the browser here. I log in, and now I have a graph interface from my environment. I set the configuration before. Now I want to see the list of connections, and I want to connect my database using a database browser. Here we are. Yeah, they connect here, and in the structure, what you have are the properties in this area. You have the visual representation in this area, and you have the commands that you can type if you need. So let me see first all the nodes that I have. You see that's the syntax. It's very similar on things that you see before. G is a graph model, and V, in that case, I want to show all the vertices that I have available in my environment. I have a button here, the run, and now they are just finding more information. There's a several tools here that provides a more nice layout to my environment. And here, my model. And believe me, those sometimes those designs can be super big, depends on the amount of connections that you have, but then can filter on whatever makes sense for you. But basically, I have here Daniel. Daniel didn't go to nowhere at this moment. We have Sueli. Sueli went to the sushi place and the burger delicious, and Alex, who were only to sushi place. If you go for each one of these items, you see the properties here that you can define. And if you want to add more things, it's not that different on things that you did before. Let me just run a command to add data. I don't need the magic word here because it's not a notebook. I like to add a new person here. I want to add Marcin, just because I see your face here in front of my screen. Marcin here, I like to add, and here we are. See, like add the relationship, everything that I told you so far. Yes, I can use notebook, or can I use a specialized tool to do the analysis. I think this kind of approach is very handy when you do the analysis, when you don't know what you are looking for. Then you can use like several queries here to filter what you need. But actually, you can also use Jupyter. I know that I use Jupyter so far only to query the base information, but now I use Jupyter for more advanced stuff. So in that moment, I'm just changing screens. I'm going to my console. I use SageMaker because yes, before I created my environment using Neptune, but I can create my own environment customized in the way that I want, especially when I want to add some libraries. I have here my environment, Neptune. I open Jupyter Lab, just a different interface. So just let you know, now I'm connecting a different Neptune. I have two Neptunes available in my environment. Neptune. Just for a matter of time, we are getting close to the end. I think in 15 more minutes I will finish, just to give you an idea about time. And here you have the command. Let me just make it bigger. You can use Python. Means that you can define the code in the way that you want. So I'm just connecting my server here manually. I use it because now is not a notebook, but let's say that you have your application, you can use similar approach. And then I have the same thing that I showed before, just more data, because I want to show something more complex. So I have several people here. Yes, I add the information, true. And here's the graph. Like, as you can see, much more complex in comparison to one that I showed before. And in that case, I focus only in people, Mary, Chloe, Gary, and every people that can imagine here. Now I want to do analysis with Josie, because I know that all these people, the new population that I have, and I know that Josie is this person. Let me see, where is she now? Josie's here. And as a question, I'd like to ask to my model, which people had a connect with Josie, because I just found out now that Josie is infected by COVID. So in terms of code, I have Josie here. and they say, hey, I want to list all the users that has a relationship with her. They are friends. And then I want to list the friend of her friends. Interesting, because I'm not going just to one level, but actually I'm going two levels. I want to count because at this moment I just want to see the person and how many connections I have, and the order, basic order by the name, the number of connections, because more people or the more Josie's friend we have, the higher the probability to have just a spread of the virus. And then I using Python command just to print those results. If you see here, I have Sue 1 and Henry 1. Just Josie don't have many connections, which makes sense. So Josie knows Charlie, and Charlie knows Henry and Sue. I know it's not easy to visualize in this way, that visualize use Python. So in that case, I have a plot. Basically, I'm using here matplotlib in terms of interface to write what I want. There's several available in market today, but now you can see much easier. You don't need a tool like Tom Sawyer. You can just create your code to do what you need. Let's have one more complex because Josie is just so easy. Let's have Terry. Terry has far more connections than Josie. And here, Henry, Colin, Emily, Sarah, Kate, and Chloe are the immediate friends. And now I do analyze the impact. So all the yellow are the first connection, and all the greens are the second connection. As you can see in a single query, I was able to identify all the people that are at risk, and then I can create my plan in order to provide a plan to try to remediate all the COVID situation. But more important than COVID by itself is the options that you have. So just to show the code, because there's no magic behind, here, basically what I'm using to show the graph is matplotlib as the library to create the graphs, or actually charts. And then this library, which is NetworkX, is a very useful library when you want to work with graph. All those technologies are open source, and again, it's up to you the best combination. Just a couple of suggestions that help you to understand what's available today. In that case, it's more useful when you have an applications. Super. At this moment, we cover data store, which is like the infrastructure to store the data. We cover query, which is all the interface. As you could see, we have more than one option to go and do the analysis. These options are different each other. And have visualization. But like in the matrix, everything that has a beginning has an end. And my final words. First, when you think about graph database, think about your use case. Graph database not for everything. There's some specific areas that can use, but when you match your use case with this technology, man, it's like a very powerful in terms of solutions and flexibility. Then, as soon as you have use case, sometimes don't need to install anything. Just go to whiteboarding and then start to design in whiteboarding the relation with your map. Because you see that after that, it's just about how to translate those graphs in terms of commands, but you have a decent perspective of your structure when you do the modeling before. Then it's about the architecture. And again, I just select this list, the thing that I showed you today, marketplace to install your environment, Neptune as a managed service, graph database on Amazon, queries, Gremlin, RDF, and then visualization, Tom Sawyer and Jupyter. But you can add things like ingestion, or maybe you can want to extract information to store in your blockchain. Actually, I had one customer who had this project, like he has analysis with Neptune, and then all the record stored in a blockchain structure. So, or you can have Kubernetes as the front end. The sky's the limit. You have several options that you can create your own architecture. Remember I told about some books, and the good news is that books are free. The Kevin Lawrence has a very interesting book that shows with much more details all the commands that I mentioned to you today. There's also a GitHub with several examples that provides everything that you need in order to move from the beginner to advanced level in terms of transversal queries. Actually, personally, I learned using this link, and it's very, very handy. SparkQL. This course is very good, a crash course in SparkQL that explains with details, much more explain to you all definitions and combinations that provide you more background. Samples, GitHub, AWS samples, there are several architectures that you can use in order to see what makes more sense and give you some insights and idea and what you can implement in terms of solution. If you want to repeat the demo that I did today, I use that link, the integration between Neptune and SageMaker in the Jupyter Notebooks. I changed a little bit just for the context, but I'd say 95% of things that I did today are available in this link. And if you go there, just define your AWS account, you'll be able to install and have all the code that I used today. And finally, you are not alone. Like graph database is not something that nobody's using. Actually, there's a lot of customers using. That slide is just a small fraction of customers that are using Neptune and graph database on AWS. Internally, we use Neptune graph database a lot, Neptune. We're using Amazon Alexa. The foundation of Amazon Alexa is based on graph database. You have customers like Netflix, they're using a lot for recommendations. We have customers like Marinus Analytics, which has a very interesting solution to identify missing people. It's a social solution. For me, it's very important because, see, today missing people is a problem in all countries, in all societies. Here in Canada, it's reality. A lot of people are disappearing. And Marine Analytics just create a solution which helps to find these people. And behind the scenes, graph database. And others, Samsung, Siemens, and others that leverage that technology in order to create a better world to live. So that said, my final words, thank you so much for staying with us until the end. My Twitter here, AlexBCBR. If you want to follow me, you'll find more information about Neptune, as well as machine learning, robotics, and blockchain. It's the areas that I'm working so far. From my side, just to answer quick questions here. Do you have one notebook per table? No, you can have one notebook per instance. So you can have as many tables as you want. You don't have any blockers for that. Actually, the part that I work at, I have more than 100 tables. We call more than 100 domains. Is it possible to do conditional inserts and places? Yes, absolutely. Condition is very strong, and the book that I mentioned has examples about how to implement conditions. So that said, that's all for me, Daniel. It's
this is amazing. Like, if you can give applause, that would be awesome. But
thank you.
Thank you. Like, just I knew it's going to be good. Like, thank you so much. Like, guys, do you have any questions for Alex? Like, this is a new area to me, but ideas keep popping up. Any questions before we go for draw? And please do the survey while we're contemplating the question, because I'll share the screen now to see.
Yeah, just one comment about Harold here. He mentioned about a book from Neo4j. I never read this book, but I know people who read it and said that it's a very good book.
Mm-hmm. So let's see. So we had way more people on the call. Only 11 did the draw. It did the survey. So the link is in the chat. So the link is here in the chat to go do the survey. You have really good odds to win any of the mining products you would like. They have tons of courses and stuff. So while other guys are getting courage to ask questions, I'm intrigued, and I like to see Alexa and kind of machine learning link there, but I still don't see like relationship between graph-powered machine learning and graph databases. Can you speak up more about that? Like, that's my confusion.
Absolutely. No, yes. Actually, there's a lot. It's a very common combination between machine learning graph database. Today, we have neural networks. We call it a graph neural networks because basically you can use prediction and neural networks to investigate across this structure. So when you think about machine learning, especially models use TensorFlow or MXNet, where the data comes from doesn't matter much. But like the example that you saw from Babylon, you see all the interface using natural language processing, and then there's a translation between language to the queries. Those queries get the process data and bring it back. When you use like neural network, you are able to do predictions. One example, I have all the structure about people, the COVID, and I know who are infected now. But based on behaviors, what the probability of having a more spread infection? We don't have the information database yet. And then your machine learning model go and helps you to do predictions based on behaviors that you have stored in your database.
I see. Thank you. Any other questions, gentlemen?
Oh, thank you, John. He just published the link. I will make the link available, the presentation available. I sent to Daniel and then you sent to everybody, but the link is this one. Thank you, Kevin. Thank you, John.
Thank you. This is awesome. Like, now you see how he inspired my planet to go deeper in machine learning. Like, there is so many opportunities in this area that people don't know about. So I'm excited to keep learning.
Yeah. There's one more question here is from Yemi. Recommendation design. I think there's a lot of things that I can talk, but I think the biggest one is focus on use case. It really easy to get lost. And believe me, the power of whiteboard is key, because when you put there and start to do simulations, like the one that I did about Mona Lisa, I think it's a great example that I do in a real life to validate things that we are doing. And because it's a NoSQL structure and you have flexibility, there's no problem to change in the future, because you see that your model just gets bigger and more complex over time. I think this key is find an engine that helps to scale, because without providing a very fast queries, the solution won't be super helpful.
Cool. Anybody else? So if you're getting questions, so you will be getting slides and the recording eventually. It takes me some time for recording, but slides will arrive shortly. And then let's see how many people did the survey. Only 11 so far. So I'm curious to see responses. So most of us have experience with Amazon. Oh, IBM, that's good. So, okay, so I'm not gonna put my name. Alex, where's your name here?
My name is not there. It's Sue. You can remove Sue. It's my wife. Doesn't.
Okay, that's okay. So if she wins, you take the book. Like you deserve that. So we use this survey to get to know like what topics to cover next. Okay, this is interesting. We see blockchain. Okay, so we'll go through this. And John, is there anything else I forgot to say or like you would like to announce while we are preparing for draw?
I don't think so. I think that's about it. It was a fantastic presentation. Very anxious to start playing with some of that technology. I haven't had a chance to. I've been a database guy a very long time, but most of the time I've spent in relational databases. And then in the last sort of 5 or 6 years, I've done a lot of NoSQL work. And I've even started doing some of the reactive event-based database work, which is very similar to like an event sourcing approach. But I have never done graph databases, so I would love to get in there at some point and fiddle around.
But now you see why my planet was inspired. Really, this is eye-opening completely, and in such area, I'm surprised how we missed on it like all these years.
Yeah, yeah.
And I knew about RDF, but I thought it was for librarians, just to organize the books. So.
Yeah, but Daniel and Jonathan, just to be fair, especially last 2 years, like if that is in the market for a while, but last 2 years for me, I see a huge demand. Like I've been working, I have experience in graph database, especially Grammarly, for about 3 years, no more than it. The last 2, I see a big spike because like COVID, like more and more, this is getting more popular and just having a natural fit. I'm confident that you see more and more sessions and more people using it from now on. And thank you, John, for your words. Really glad that you like it.
Yep. Okay.
I added your name as well to the spin, so no more names. Anybody who wants to go for a draw that's still with us? Going once, going twice, 3 times. Okay, let's spin.